Hello everyone, it's Logan here, and back after a very long absence from YouTube, and there is several reasons for it. I haven't posted very many videos about my go-kart because quite frankly it's not working. So after I left off with my last video, I made the control box, I mounted it to the go-kart, and it immediately didn't work. Very, very frustrating. So I tried to fix it, I couldn't, and then Minnesota winter set in. It was negative 10 degrees outside, I'm not going to be working on it. And then I lost my camera woman, and then after that, work started requiring 60-hour weeks, lots of overtime. But I am back now, and I started working on this control box again. And I think I figured out what the issue was. So the next thing to do is to basically lay it out totally differently and rehook it back to the go-kart, and I think it's going to work this time. I think I figured out what the issue was. Let me switch camera modes here. Okay, so here we are. Now it's not nearly completed. I still need the second one, which is over there, the second heatsink. Need to put all the transistors into it. It's going to sit, you know, right here behind that one. This is going to get moved back. These are all going to get zip tied in there. Anyway, you can see it's totally different. These are going to be laying flat this time. I may or may not put the heatsink on top of it. We'll see. Obviously, the fans are going to go here and here. But there's quite a few different things on this. I want to cover a couple things from my last videos here. First thing, when I was talking about the NPN layout, don't even pay attention to that. Yeah, I don't know why I even saw it work. In theory, it shouldn't even work. I confirmed this with an electronics friend of mine. This is the new circuit, which looks pretty complicated, and it actually doesn't cover even everything that's going to be in the go-kart. But I'll give you an idea of how this works here. This is the finished circuit that I have. So what's going to happen is, here's the batteries. Now, they can be effectively any voltage, but I have two regulators that can handle up to 30 volt inputs. So for now I have to keep that at 30 volts or less, unless I get another regulator to drop it below 30, which I probably will end up doing eventually. So I have a switch here. Basically from the battery it's going to go all the way to the front, to the steering column, to the switch, and then back inside here to these regulators, which are right there. Now this bottom one here is going to do battery voltage down to 15 volts, and then this one takes 15 volts and brings it down to 5 volts. Okay, that's what we're showing right here. The 15 volts is for two reasons. One is powering the case fans, which are cooling the control box. But also, the more power drop, the more voltage drop these have to handle, the more heat they generate. And all they have is a little tiny heat sink right there. So I figure if I can drop from 15 to 5 instead of 30 to 5, that would be even better. And effectively, this sends power two ways. The most important way is out to the pedal, where I have a Hall sensor. When the pedal gets pushed down, the magnet activates the Hall sensor, which draws power, sends power back there. But then it also sends a signal right here to this transistor. It's a TP107. That's important in a second here. That draws power directly from the 5 volt. And sends power out at 5 volt up to the Hall sensors inside the motor. Now right now each motor has 3 Hall sensors, one for each phase. There's 2 motors, so therefore 6 Hall sensors. When in phase 3, when I upgrade the motors, that's going to double. But for now, and of course that sends power back there, sends a signal to another TP107. Now the last video I made, I was using these little guys, which are basically PNP transistors, just like the TP107, but they're smaller. I was hoping I could get away with it. The problem is, and you can see this motor running, it is being powered by that transistor right there, or IGBT rather. The problem is, as I turn that up, boom, you can hear it quit. And I couldn't figure out why it was doing that. When it got above like 10.5 volts, it would start failing. And what I realized is that by touching this, I could feel it was getting really hot. And once I got up above that threshold, it tripped the current or the temperature limiter and just shut off. So these are simply not good enough to handle the voltage I need to throw at them. So we are switching now to the TP107s, which can handle, I shouldn't say voltage, but handle the current. These can handle 8 amps. Now this whole thing is important because the Hall sensors I have are not able to send out 5 volts. They're actually less than 5 volts. If you know of a Hall sensor that will put out above 5 volts, I would appreciate hearing about it in the comments, because that would allow me to eliminate this transistor. But that sends out a signal to the IGBTs, and I figured out how to make these run. Effectively, we need this current limiting resistor, basically. I'm using a 1,000 ohm or 10,000 ohm, I forget. I think it's. And the reason for that is because these gates on these IGBTs don't just need a voltage, they actually need a current flowing through. Now, on the old way that I had this hooked up on the simple motor, it was easy because they could just have a resistor going right between these two, sending power right back through, because everything was running at the same voltage. However, these are drawing power directly from the battery. So they could be at 30 volts, but the signal they're getting is only 5 volts. So what we have to do then is shunt it off there and back to the 5 volts. So as long as they feel a current going through there, they will activate. And what they'll do then is send the power through to the coil, activating the motor. And so of course, we have 3 sets of these for each motor. I'm going to be using 2 for each coil, because even though they can take up to like 75 amps, I still want to keep them a little bit cooler, no more than 30 amps. So in this control box, I've done a couple of modifications. One, I've got fuses on here. Those are set at 30 amps. So each IGBT will get 1 fuse. And right here, this is DIN rail. I actually learned about this through all the electrical work that I'm doing at my work here. This is called a DIN rail, and this is connectors. And these are little jumpers that go between them. So it makes it way easier, and I don't have to solder things, because before, I got this all hooked up to my go-kart, and the wires are coming through the hole, and then I had to solder them where they had to go, and I had, wires like this here, which I had to solder, and then I ended up having to just clip all the wires, and yeah, it was no good. So this is the new setup, and it's working, as you can see, perfectly. So really the only thing to do now is to complete it. I still need a few more connectors. I ordered more because I ran out, so basically I'm going to do a 3rd one for each of these, and then 6 more here. So the phase power is going to come from the battery in there, through there to the fuse, and by the way, these can take 30 amps each. And then from the fuse to the IGBT, from there out to the 24 volt power connector, just like you'd have on a computer motherboard. Oh, come on. Go over here. Okay, I moved it out of position now. And then it'll come out there to the wheel motor. And then from the wheel motor, let's get that back in there. And then from the wheel motor, it's going to go back into there, out of there, back down to the negative power. Now this out here is that shunt. And if you remember all the way back from one of my very early videos, I explained how that shunt is working. The only thing I can't figure out is how to make it run off the same power source, batteries or voltage regulator or whatever. Right now I have to have a separate, like a 9-volt power supply for it, but it's like it detects if it's in loop with all the other power supplies. Now, just a shout out to these. I got these off of eBay. These are absolutely fantastic. They're programmable. So I can set, it'll take whatever input voltage and I can set it to the output voltage. Right now I have this set at 15, it's only showing 9.7, but the reason is because it's only being given 9.8. But if it's given 15 or more, it will stop it right at 15 volts. And then this here is taking whatever incoming voltage and regulating it to right about 5.25 volts, or you know, it's bouncing between 5.2 and 5.3. So it will then regulate it to that regardless of the input voltage. And it's running from these to the DIN rail connectors. So hopefully in the next week or two, I will be back with a video that actually connects, shows all of this connected to the go-kart and running, assuming that the motors still work. So thanks for checking this out. I'm happy to answer any questions you have, and stay tuned, get subscribed if you haven't already, because I will be back soon with another video. Thanks for watching and have a great day.